Hello, this is our first lesson in Math 2 or Honors Math 2. It is Chapter 10 from the Book 1 of Big Ideas Math. If you do not have these packets, the virtual students, hopefully you did pick one up, but they are available digitally, so I can make sure that you have that or access to it. So please take notes. I don't want these videos to be terribly long, so I am going to get started right away. If I am going too fast, obviously pause the video, take your time, and always let me know if you have questions. So we have parallel lines. First thing that we're going to be talking about. So parallel lines are considered to be two coplanar lines that do not intersect. So coplanar means that they're in the same plane. Like this piece of paper is a plane. Technically a plane, so you might have learned this in chapter 8, goes on in all directions. So they usually represent it with a rectangle or a parallelogram when they have to do it on paper, but you have to remember that it does go on forever and ever. So they are in the same plane and they do not intersect. So a picture of two parallel lines. Lines keep going forever and arrow, hence the arrows at the end, are two lines that would never intersect. This line could be called line AB because A and B are 2 points on the line. This one, CD. Sometimes lines are also represented by cursive letters kind of at one end or the other, like M and N. So to identify parallel lines, there is a symbol, and parallel looks like that. Sometimes in the book or when it's typed, they're straight up and down. So you can see that if you look down a little bit, right at the bottom here, they have FE parallel to AC. So that's what that symbol means. So in this particular picture, I could say AB is parallel to CD. Or I could say, and they usually write out the word line M is parallel to line N. So parallel lines do not intersect. Skew lines are a little bit trickier to understand. They are also lines that do not intersect, but they're not parallel because they're not in the same plane. So the best way to represent that is to have a box, like a three-dimensional shape, which is not always so easy to draw, but looks like that. Then, if you have a line that is coming out at you, so if you picture a box on top of your desk, the upper right corner is coming out at you and it's above the bottom front of the box. So they don't intersect, but they're not going in the same direction. So that's what you need to try to remember, is that skew lines are different because they are going in opposite directions and do not intersect. So that's the difference between the two. Planes can be parallel, so you can have the floor and the ceiling, for example. So if you have a plane T, so a lot of times a plane is represented by a parallelogram and then it has a capital letter in the corner. This plane is underneath it. We'll call it plane U, but on top of each other, but they don't intersect. And again, you can label it by saying plane T is parallel to plane U. Perpendicular. Perpendicular lines are lines that intersect to form 90-degree angles. A lot of times a 90-degree angle, to know for sure that it is exactly 90, you'll have the little box in the corner to show you that it is. So perpendicular lines, it doesn't have to be perfectly horizontal and vertical, but they have to form 90-degree angles. So that's a picture of perpendicular. The symbol for perpendicular looks like that. So if I were to actually label these A, B, C, and D, I could say that AC, that line, is perpendicular to BD. Okay. All right, so I want you to take a little time and look at these questions and see if you can answer them. So you might want to pause the video because I'm not going to just have free airtime. But it says, think of each segment in the figure as part of a line, because technically lines keep going forever and ever, and this is just a segment. But which line or lines, plane or planes, appear to fit the description? So they're always referring to point A for this set of questions so that we don't have to name too many lines. We can just pick the one that contains point A. But in this picture, if a line is going to be parallel to CD and contain point A, then it's going to have to be AB. Remember, it has to be in the same plane. Whether you just put AB or AB with a segment above it, all is good with me. Lines that are skew. So but it has to contain point A. So if this line is coming out at us on the left side, this line right here, AH, is up and down, and because they're in different planes, they will not intersect. So AH, on paper, they look like they'd intersect, but three-dimensionally they would not. AG is another one. It's just diagonal, but it still would never intersect CD because it's on the other side. Perpendicular to CD, so you can see where that little box is, that tells you that that is specifically a right angle. And if it has to contain point A, the only one then would be AD. And parallel. Another way to name planes is to use three corners, three of the four, any three of the four. So E, F, G, they're talking about the bottom of this cube. And so if it's going to contain point A and it has to be parallel to it, we need to name the top. So we will call it plane ABC, but any three of the four letters A, B, C, D would work. Okay. One important thing to note, do you see these little triangles? In this picture here, they are pretty small, but they are telling you by putting those there that those two lines are specifically parallel to each other. Okay, so name a pair of parallel lines. DE and, whoopsie, not DE. These two don't have any markings on it, so I do not want to make the assumption that they're parallel. Since these do have the markings, they're telling us that DM is parallel to EF. Okay. Perpendicular lines, look for the box. Certainly it looks like CD is perpendicular to DM, but there is not a marking there to specifically state that. So I want to be sure, and I will say BM is perpendicular to MA. If you didn't say BM, but you called it BF, that's the same line, so it wouldn't have mattered. Oh, I made a mistake. MA, point A is down here, so I have to call it MD, not MA. MD and BM are perpendicular. Is FE parallel to AC? No. And why? Because they would intersect. So you have to picture that these lines, see the arrows, they go on forever and ever, and since they would intersect, that means that they are not parallel. Okay, turn the page. This is important information, so hopefully you can see all of it. I think so, because I'm going to draw one big picture over here and I'm going to use it for all of these explanations. First and foremost, though, we have transversal. A transversal is a line that intersects two or more other lines, coplanar lines, at different points. So draw a line, draw another line, and then if a line cuts through both of them, so it intersects these two lines at two different locations, that makes this line, we'll call it T, a transversal. So line T in my picture is a transversal. I guess it's the only one in this picture. When this happens, when you have a transversal cuts through two other lines, you end up with a whole lot of angles. So I'm going to number these angles. This is angle 1. Next to it can be angle 2, 3, 4, 5, 6, 7, 8. So 8 angles. We have different clusters of angles. That's how I like to refer to them, because I expect you to know and be able to identify these 4 types of angles. So this is one cluster of 4. This is another cluster of 4. Corresponding angles. There are 4 pairs of corresponding angles. It says that they are in the same relative, so corresponding position. So when you look at this cluster of 4 and this cluster of 4, angle 1 is in the upper left, so is angle 5. So they are a pair of corresponding angles. So are angles 2 and 6, upper right, angles 3 and 7, lower left, and angles 4 and 8, bottom right. So those are corresponding angles. Some books refer to these types as same side interior. I often use the word consecutive, but they mean the same thing. Angles have to lie in between the two lines. So the angles that are in between the two lines are 3, 4, 5, and 6, and they have to be on the same side of the transversal. So for example, 3 and 5, angle 3 and angle 5, or on the other side, 4 and 6. Alternate interior angles. Look at the words and make sense of them, because then it helps to identify them. Alternate sides of the transversal inside the two lines. Alternate interior. 3 and 6. One example of alternate interior angles. 4 and 5 are the other pair. And then lastly, alternate exterior. So they have to be outside the two lines. 1 and 2, 7 and 8 are considered exterior angles. And then alternate sides of the transversal, angle 1 and angle 8 are alternate exterior. So are angles 2 and 7. So again, maybe pause the video, look that over, and then try to identify in the picture below all the types of corresponding angles: alternate interior, alternate exterior, and consecutive. So the pictures are different because the two lines are more vertical than in my initial picture example. So you still have to be able to identify those types of angles. Corresponding angles are in the same relative position. So therefore, in this picture, upper left, angle 1 and angle 5. And if you look above, there are 4 pairs of corresponding angles. So angle 2 and angle 6, upper right and upper right. Angle 3 and 7. So it looks like they end up being the same numbers, even though they're kind of in different spots. Angles 4 and 8. Alternate interior. Interior means inside. Alternate sides of the transversal. 2 and 7, one pair. 4 and 5 is the other. Alternate exterior, outside the two lines, 1 and 3, 6 and 8, and alternate sides of the transversal. This is T, the transversal. So alternate exterior, angles 1 and 8, as well as 3 and 6. Consecutive angles, consecutive interior angles, are usually the hardest ones to remember for some reason, but one way that I remind kids of them is that they make a U. They have to be inside the U. Sometimes the U is upside down, sideways, but inside those little corners, like 2 and 5. And then the other U, which would be upside down, would be 4 and 7, those two pairs of angles. Couple more examples on the next page. Look at each of these pictures and try to identify which type of the 4 they are. So maybe pause it, try, and then see if you get it right. So in this picture, this is my transversal. It cuts through the other two lines, upper left, upper left. These are corresponding angles. Over here, this is the line that cuts through the other two lines. So this is a little bit different looking picture maybe, but they're outside the two lines and they're on opposite sides of the transversal. That makes them alternate exterior. This picture doesn't look so good, but I'm assuming angle 4 is that one and angle 5 is this. And so therefore, they're inside the two lines, alternate sides of the transversal. They are alternate interior angles. Alternate interior angles sometimes make a Z. The Z isn't always like a Z. Sometimes it can look more like an N or be upside down. But when you have a Z, whether it looks like this or like that, if they're in the little corners of the Z, they are considered to be alternate interior angles. Thank you.